P series and harmonic series. Starting from P series, that is a summation, n goes from 1 to infinity, 1 divided by n to the p, so that is 1 over 1 to the p, 2 to the p, 3 to the p, 4 to the p, and then keep on adding. So we call this a P series. A P series, the p is only a parameter. And then p, the p can be equal to 1, and then the p can be greater than 1. What happens when p is equals to 1? When p is equals to 1, this is a very famous series called harmonic series. Harmonic series is always diverge. So we replace the p with a 1. So that will be 1 to the first power. The power is not going to change. We only change the base. Okay, this one is always diverge. The harmonic series is always diverge. So even though the term 1 over n, so the terms 1 over n, so 1 over 1, 1 over 2, 1 over 3, and then as we move on, so even though the terms get smaller as n increases, so as the base increases, each fraction is getting smaller, 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 and smaller, right? And they don't shrink quickly enough to make the total sum finite. So they don't shrink quick enough. So that means when you add them, you have to keep adding them, and then the sum is not going to shrink quickly enough to make the total sum finite. The series grows without bound, meaning that the sum becomes arbitrarily large as more terms are added. So as you keep adding more and more fraction, the sum is going to become arbitrarily large. So that's why the series, this harmonic series, is always diverge. So let's just write how about this? Let's write this down. The harmonic series. So as the base, so we will say as n increases, the sum. Okay, the terms. I should say the terms don't shrink quick enough. So that means from 1 over 12 to 1 over 13, the next term is not going to getting so small that is the next term doesn't shrink quick enough to make the total sum finite. The series grows without bound. The bound refers to upper bound, lower bound. Without bound. Because if a series converges, as you add more and more terms to it, the sum approaches to a certain value. That's why we take the limit. As n approaches to infinity, as you look all the way to the right hand side of the series, you can see that those values are getting smaller, and then when you add them up, the sum approaches to a certain real number. So that refers to the bound, meaning the sum becomes arbitrarily large. As more terms are added. All right, that is a harmonic series. And then we have a P series. So P series is P is just a P. When P is equals to 1, we have a harmonic series, always diverge. What about when P is greater than 1? And then after that, we will explain what happened when P is between 0 and 1. Okay, let's do the next part. The next part is when P is greater than 1. How about we try a large P? P is equals to 1,000. And then this one, I can tell you that the series converges. And then we have a summation. N goes from 1 to infinity, 1 over n to the 100 power. So this one, you can see that the next term shrink quick enough that is equals to 1 to the 100 power, and then 1 over 2 to the 100 power, and then plus 1 over 3 to the 100 power, plus 1 over 4 to the 100 power, and then we still keep on adding. We keep on adding. So in the previous series, the harmonic series, I said the terms don't shrink quick enough to make the total sum finite. But this one, take a look. This one, except the first term, take a look at this. You have 2, 3, 4 raised to a very large value, and then 1 divided by that is nearly 0. You are adding up so many these terms together, the terms shrink quick enough, so the sum is just nearly a 0. And then the first term, the sum is equals to 1. So this one, I can say that the sum is approximately equals to 1, and n is a finite. The sum is finite. And then we say the series converges. That's it. When p is greater than 1. What about when p is between 0 and 1? Let's do it. So when p is between 0 and 1, not including 0, because when p is equals to 0, and then the denominator is just a 1. And then let's try p equals to 0 point. Let's try something small. How about 4 zeros? This. And then I can tell you that the series diverges. Okay, let's draw the series. Summation. N goes from 1 to infinity, 1 over n to the 0.401. And then that is equals to 1 over, and then I will increase the base. All right, and then plus. Okay, and then you can keep on adding. So this one, let's do a 4. And then keep on adding. So this one, let's grab one of them. What is this equals to? 1 over 3 raised to this small exponent. What is that equal to? That is approximately equals to 1 over 3 to the 0 power, which is 1 over 1 equals to 1. But you are adding up infinitely many copies to 1. So you sum up infinitely many copies. Infinitely many copies of 1. So that means you have infinity times 1. Infinitely many copies of that is equals to infinity. And then therefore, that is your sum. So that means the series diverges. Alright, so that is the basic of P series and harmonic series, and we will do more exercise in the next video.